Good morning everyone. Today I want to discuss about Luthor-Meyer's curves. Yesterday class I discussed about that Dauberner-Triad's law and also Newland's octave rules also completed. Now today I will discuss about Luthor-Meyer's curves. Luthor-Meyer curves. According to Luthor-Meyer curves, he took the basic point to classify the elements. That is one basic point, atomic volume of the element, and another basic point, atomic mass of the element. He draw a graph between atomic volume and atomic mass of the element. Based on that graph, he arranged the elements in particular groups based on that curves. Okay, according to Luthor-Meyer theory, he follow that rule based on atomic volume of elements in centimeter cube, volume means, and also atomic weight of elements, that is grams. Say according to Luthor-Meyer's theory, it is in graph, it is x-axis and it is y-axis, x and y-axis. In x-axis and y-axis, now here atomic volume taken in x-axis in centimeter cube, atomic mass in x-axis, atomic volume in y-axis. See, it is 0, 20, 40 centimeter cube, 60, 80 and 100 like that. Here 10 atomic mass, 20 like 30, 40 and 50, 60, 70 like this. See, generally according to atomic mass, see here one peak obtained here for lithium, another peak obtained for here, that is sodium, another peak obtained for that is potassium, another peak obtained from rubidium, another peak obtained from cesium. Generally after lithium, see this is starting element lithium, and another element is beryllium, and another element is here carbon, and after that increase like this. Here fluorine present, here fluorine. After that again down it is magnesium, and here they took like silicon, phosphorus, again increased, that is here chlorine present, again decreased, like calcium present, like this, again increased, again decreased, again increased, like this. So these are curves are known as Luthor-Meyer curves. In that curves based on atomic volume and atomic mass, he arranged curves. All peaks are occupied by lithium, sodium, potassium, rubidium, cesium. So the elements which are occupy similar positions in the peak, they are belongs to same group. They are exhibits similar characters. See, if you observe this, lithium, sodium, potassium, rubidium and cesium all are occupies peaks. So lithium, sodium, potassium, rubidium and cesium all are occupy peaks. They occupy peaks. So then these are belongs to same group, means these elements are exhibit similar characters. These elements are exhibit similar characters. And the descending position, see here in the line descending position, here it is descending position, here it is descending position, here strontium present, here barium present. In the descending position of the peak, all position similar elements, that is beryllium, magnesium, calcium, strontium and barium. And ascending position, fluorine, chlorine, bromine, iodine. See in the line ascending position, the ascending position similar elements are attained, that is fluorine, chlorine, bromine, iodine. See in the curves, the similar points exhibited by the similar points are occupied by the elements are belongs to same group according to Luthor theory. For example, if you observe that, if you observe this curves, all peaks are occupied by some elements. So the peaks are occupied by some elements means they exhibit similar characters. They exhibit similar characters. See here lithium, sodium, potassium, rubidium, cesium. Understood? These all are occupies that peak point. These all are occupies peak point. So due to this they are exhibit similar characters. And if you observe this descending line, in that descending line beryllium, magnesium, calcium, strontium, barium, similar positions are occupied. Then they are also exhibit similar characters. In ascending position, if you observe ascending position, here fluorine, here chlorine, here bromine, here iodine. So these are also exhibits similar characters. So based on that Luthor-Meyer's theory, the elements are arranged in the particular groups. But this theory also not explain about so many elements, particular physical and chemical characters. So after this, the Newlands completed, Luthor-Meyer completed, Dobereiner completed. After completion of these scientists, the another theory is another periodic classification proposed by, another periodic table proposed by Mendeleev. Mendeleev constructed periodic table. The first Mandeleev constructed periodic table in the form of groups and periods. Groups and periods. Now, this is Luthor-Meyer's theory completed. After completion of Luthor-Meyer theory, the next theory is known as Mandeleev periodic theory. Mandeleev periodic classification. Classification of elements based on Mandeleev theory. According to Mandeleev's, Mandeleev constructed periodic table based on atomic weights of elements or atomic mass of element. Atomic weights of elements or atomic mass of element. He constructed periodic table in the increasing order of their atomic weights. In the increasing order of their atomic weights or in the increasing order of atomic masses or atomic weights. Both are similar, atomic weight or atomic mass. He constructed periodic table means according to Mandeleev, the physical properties of the elements or chemical properties of the elements, periodic functions of their atomic weights. The physical and chemical properties of elements are periodic functions of their atomic weights. Means the physical and chemical properties are depends on atomic mass of the element. Depends on atomic mass of the element. So according to this, the Mandeleev constructed vertical columns and horizontal rows. The vertical columns are called groups. Groups or families. According to Mandeleev periodic table, the vertical columns are called groups and horizontal rows are called periods. The horizontal rows are called periods. The vertical columns are called groups, the horizontal rows are called periods. There are 8 groups present in Mandeleev periodic table. 8 groups before discovery of noble gases. And here 6 periods present in Mandeleev periodic table, and here 8 groups present in Mandeleev periodic table. At the same time 6 periods present in the Mandeleev periodic table. Here the first 3 periods are short periods, remaining are long periods. Okay, but in the Mandeleev periodic classification, the vertical columns are called groups and the horizontal rows are called periods. See, generally Mandeleev considers the elements like this. It is 1A group 1, second group and third group and fourth group and fifth group and sixth group and seventh group and eighth group, like this. These are known as groups. See, first, second, third, fourth, fifth, sixth, seventh. Okay, like this. And horizontal rows are called periods, like periods. These are periods. Take here the Mandeleev arranged elements based on their physical characters and also chemical characters. Based on their physical characters and also chemical. These are called periods. See, periods. These are called groups according to Mandeleev periodic table. Generally, Mandeleev is based on the elements reactivity with oxygen and hydrogen. Oxygen and hydrogen. He constructed the periodic table based on the atomic mass and also took the chemical reactivity of the elements based on oxygen and also hydrogen. Because oxygen and hydrogen are most reactive elements with the other elements. So, according to hydrogen, in first group RH formed. R means elements. In second group RH2, because this is second group element. In third group RH3. In fourth group RH4. In fifth group again it is RH3 decreased. In that next one is RH2, RH, and finally now RH0. Here based on hydrogen, he constructed a periodic table based on hydrogen and also based on oxygen. According to valency, hydrogen valency 1, R1H, second group RH2, third group RH3, fourth group RH4. From fifth group, number of unpaired electrons decreases. That is R again decreases, RH3, RH2, RH0. Then no need to write here. But according to oxygen also there, according to oxygen, if you take oxygen valence is 2, then oxygen valence is 2, RO, it is 2, RO2 and O1, and RO 2 cancel, 2, no need to write 2. So R2O2 means it is second group. Okay, now you can directly write RO, and it is oxygen valency 2 and R valency 3, R2O3, and here also R2O4. Then took common, then it is RO2, and another one is R2O5, it is R2O6, then common RO3, and finally R2O7, and it is R2O8. Then R2O8 means you can take RO4. So according to oxygen, their arrangements are also given in the periodic table of elements. Okay, generally Mandeleev's periodic table constructed based on atomic weights of elements and also characteristics, chemical reactivity of elements with the oxygen and hydrogen. So based on that characteristics, the elements are arranged. Like hydrogen, see, like hydrogen here in this group, in this first period, hydrogen present and lithium present and sodium present, all are exhibit similar characters, all are forms with this R2O compounds. For example, take lithium hydrate LiH, sodium hydrate NaH, oxide, lithium oxide Li2O, sodium oxide Na2O. See, these elements exhibit similar characters. Understood? Based on that formula also they are exhibit similarities. See, for example, take fifth group. Here nitrogen present, NH3. Understood? Here NH3. Or it is, if you write O, oxygen 2 and nitrogen 5, N2O5. So according to the only nitrogen can forms this type of compounds. With hydrates forms NH3, with oxide form N2O5. In this group, the elements which are forms like this, forms compound with hydrogen, they must be present here only. They must be right here only. So based on chemical character also, periodic table arranged. Understood? The elements are present in periodic table. So tomorrow I will explain about the Mandeleev's periodic table remaining part. So this is according to chemical character. Okay, that chemical nature of oxygen and hydrogen. Generally Mandeleev's periodic table constructed based on atomic weights and chemical characters of the elements with oxygen and hydrogen. Okay, the vertical columns are called groups. See, 8 groups are arranged. The horizontal rows are called periods. Understood? Tomorrow I will explain about total Mandeleev's periodic table. Thank you one and all, and read your material and textbook and then do some objective bits. Thank you very much. Good day everyone.